Hello, my name is Joshua Kelling, and this is my theory on the Mpemba effect. My theory idea actually started while I was going on vacation, and I read about it, and I decided to give it a try. And I was thinking about a week before we took the vacation about what it could be, and I found flaws in just about every theory. But while I was riding on the airplane, I thought of different air currents and how warm air rises and cool air falls. And I remembered that that also applies to water. So, with warm water, does it rise and fall just like air, even in smaller amounts? Okay, so for my idea for the Mpemba effect, or my theory, what I did was I thought that warm air rises and cool air falls. But as you add more as you decrease the energy level or the temperature, it becomes an egg shape. To where what happens is, as you have cold pushing in on it, warm air and the cold air the rotation starts to get smaller and smaller, and rotation speed starts to slow down as the momentum is the only thing that keeps it going after a while. Okay, so what I have here is I have two regular water bottles. Both have already been filtered and both have already been boiled. I have one bottle of sparkling water, otherwise known as water with CO2 in it. I have a measuring cup that uses liters and milliliters on it, and I have a thermometer which has centigrade and Fahrenheit on it. Now for my experiment, what I did is I took a measuring cup right here and I filled it up with water. 1 cup, or actually about 1/4 of a liter or so. And what I did is I boiled both of them, I filtered both of them, and I put one of them in the fridge, and I left the other one to sit. And what I did is during the meantime while I was letting that one sit, I took another 1/4 of a liter of water, I boiled it, and what I did is I put shavings of dried potatoes in there. And I know that this sounds weird, and I probably should have done a different medium, like wood shavings, or not medium, but something else. And what I found out is, okay, so I put my 1/4 of a liter of water, and I have my potato shavings, and I have my thermometer right here. And what I'm going to do is I'm going to put that into the microwave for 2 minutes on high, 1200 watts. Starting temp is 12 degrees Celsius. Now what's probably going to happen is it's going to boil, or at least simmer some, and then I'm going to put these inside of it and see whether or not it rises. Okay, so our water's been boiling for 2 minutes. Temperature has shot up. It's at about 90 degrees Celsius, 92 degrees Celsius. So I'm going to take some of my flakes and let's see if it floats. As you can see, right there, it's floating up, comes to the top, it's coming back down, and it keeps on going, almost in a circle. It'd be better if I turned it this way. Next, I'm going to show you that boiling actually does take out particulates, mainly CO2 and other things that can become airborne. Okay, so what I'm doing is I am taking my CO2, carbonated water, and I'm going to pour 1/4 of a liter in. Next, I'm going to put in the microwave for 2 minutes, just like the other one that I did. Same glass container. Now, as you can see, the water is boiling along with all the carbon dioxide that was inside of it. It's actually being released into the microwave. So right now what I'm doing is I am performing a test to see which cools faster. I am making a chart out of it on my phone, which I'll show you later, comparing the hot and cold. I'm checking on it every single minute, writing down what it is on the chart in Celsius every single minute for 85 minutes, because that's how long it took for the hot water to cool down. I'm not sure if it'll take that long for the colder water to cool down. I had an idea. Since Mpemba's conclusion came from ice cream, and ice cream contains mostly milk and a couple of sugars and additives, I thought it would be fun to try a comparison between water and milk to see whether or not any of the components inside the milk make the liquid cool faster. I'm taking a regular glass of milk and heating it up, and right now I'm trying to cool it down to 60 degrees Celsius just so we can have a comparison of equal values. I've also had 1 liter of both. That's going to be my cool test. And I'm going to put it in the freezer for 50 minutes or until it freezes. Then I'll have a side-by-side comparison. After 50 minutes, I'll do a separate test just to see how long it freezes and whether it stair steps, just like the water did after 15 degrees Celsius. Now what I did to test the Mpemba effect was I actually got 2 1/4 liters of water. I put them into identical cups. I chilled one to about 10 degrees Celsius, and I boiled the other one to about 90 degrees Celsius. Then I put them both inside the freezer, checked on them for 1 minute, for 85 minutes, or until they froze. And these are my results. Okay, so this is my graph that I made. I have a control. I did hot milk and cold milk just because Mpemba actually produced his results with ice cream, which is made mostly of milk. Then I did hot water and cold water. And it's actually kind of weird because what happens is that while you start higher up here, you actually start to get lower and lower, and it starts to get closer and closer until it starts to stair step. Same thing with cold water. It starts lower and it starts higher, but this actually seems to go down a lot faster than the colder water until it reaches about a stage to where it's almost an equidistant apart from each other, except for maybe the warm water, the control, and the cold water are almost equidistant, such as the warm milk, the control, and the cold milk. I actually had my doubts about this effect when I first started. So what I first did is I actually tried it to where I got some cooler water and I got some room temp and some warm water just to test it. And the room temp water actually did freeze faster than the cooler water. Although I have seen this effect in real, because I put 2 cups filled equally with water, equidistant apart from the freezer generator, and I've watched it, and although I think the warmer water does freeze faster. Now, we don't actually even know if the effect is actually real. It could just be that Mpemba and his professors actually put the ice cream just closer to the thermostat which made the freezer go colder. If you produce this in a house test or something similar, you could actually get the same results if you place it closer instead of further away from the thermostat. If you place it too close to the thermostat, heat could actually radiate off of the heated water, or ice cream in Mpemba's case, and it could actually make the thermostat think that it's hotter in the fridge than it really is, making it work harder and longer than what it actually should. Now, I know that I didn't really talk about this very much, but the speed of the circulation in correlation with the temperature. Well, what I did is actually at about 80 degrees Celsius, it moves at about 1.5 centimeters per second. At 85, it moves at about 2.5 centimeters per second. At 90, it moves at about 3.25 to 3.5. I actually have a reason for not going above 90 degrees Celsius very much in my experiments. It's because that once you go above 90 degrees Celsius, you actually lose most of your water through boiling. Well, not most of it, but some of it through boiling. And you can't really measure too much past that, because once water reaches 90 degrees Celsius or 212 degrees Fahrenheit, then it is going to boil off, and you cannot measure how hot it gets after it turns into gas, unless you have the type of equipment to do that, which I do not have.